Welcome to the session on correlation, linear regression. The objectives for this session are to interpret the coefficients of a regression line equation for bivariate data. Bivariate data can be represented on a scatter diagram with the independent variable on the x-axis and the dependent variable on the y-axis. Suppose we have a scatter diagram looking something like this. When a scatter diagram demonstrates correlation, we can draw a line of best fit. But which is the line of best fit? Is it this one? Or this one? Or this one? Let's see how we can find the best line. One type of best line is a least squares regression line. We're going to discuss the ideas surrounding this in the next few steps. Before we do so, let's introduce ourselves to some notation. Suppose x1, y1 is a point on the scatter diagram as shown. The distance between that point and the line of best fit is called d1. Similarly, the distance between x2, y2 and the line is called d2. The distance between x3, y3 and the line is called d3, and similarly for x4, y4. So each point xi, yi is a distance di from the line. The method of least squares minimizes the distance d1 squared plus d2 squared plus d3 squared plus d4 squared. More generally, it minimizes sum di squared. The regression line of y on x is written in the form y equals a plus bx. Given a set of bivariate data, you can use a calculator to find constants a and b. Do note, the order of the variables is important. The line y on x is different to x on y. The coefficient b gives you the change in y for each unit change in x. Suppose we have positive correlation, as shown in this diagram, so as x increases, y increases. Then if we have a line of best fit, y equals a plus bx, the coefficient b will be greater than 0. However, if we have negative correlation, so as x increases, y decreases, then our line of best fit, y equals a plus bx, has a coefficient b which is less than 0. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. The table on your screen shows the ages of some ducks and the number of eggs they laid in a month. The equation of the regression line of y on x is y equals 16.333 minus 0.0602 times x. Sketch a graph and describe the correlation between the two variables. So here's our graph. We have the age of the ducks versus the number of eggs laid in a month. Notice that there is a strong negative correlation between a duck's age and the number of eggs it lays. So the older a duck gets, the fewer eggs it lays. Now interpret the value of the gradient of this regression line. So we first need to determine what the gradient is. Now, in the equation y equals 16.333 minus 0.0602x, the gradient is the coefficient of x. In other words, the value minus 0.0602. What this means is, if the age of a duck increases by 1 month, then the number of eggs it lays decreases by 0.0602, because of course the coefficient is negative. In Part C, you are required to justify the use of a linear regression line. So for this we need to look at the way the dots are moving through the scatter diagram. So the correlation indicates that there is a linear relationship between x and y. Therefore, a linear regression line is a suitable model. We are now going to consider estimates from the line of best fit. Which estimates are more reliable and which estimates are less reliable? Consider the regression line of y on x. It is written in the form y equals a plus bx. If we are estimating for values within this range, as shown in the diagram, it is more reliable. However, we need to ask ourselves, does the pattern continue outside the range of given values? If we are estimating values using the line outside this range, it is less reliable. Let's now consider the formal definitions of interpolation and extrapolation. Use the regression line to make predictions of the dependent variable which are within the range of data given. Interpolation is the process of making a prediction based on a value within the range of given data. Extrapolation is about making a prediction based on a value outside the range of given data, and this is less reliable. Let's now take a look at this example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's consider example 2a first. The table on your screen shows the ages of some ducks and the number of eggs they laid in a month. The equation of the regression line of y on x is y equals 16.333 minus 0.0602x. A farmer wants to estimate the number of eggs a duck will lay at 10 months and 130 months. Comment on the reliability of these estimates. So let's have a go at this. The prediction at 10 months is outside the range of the data, so is not reliable. Notice that the lowest age we have in our range is 20, and 10 is less than that. However, as 130 months is within the range of the data, as shown here, it is more likely to be accurate, so as we would be interpolating. Now let's consider Part B. Comment on the suitability of estimating the age of a duck which has laid 14 eggs using this regression equation. Now the independent variable in this model is the age of the duck, x. This model should actually not be used to predict a value of x for the given y. Instead, you would need the regression line of x on y. This brings us to the end of this session. If you have understood its contents, you should be able to interpret the coefficients of a regression line equation for bivariate data. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.